Hey, it's time for the hot dog eating contest. So, I'm going to give you a problem to start off. It says Nathan can eat 21 hot dogs in 6 minutes. Whoa! That's a lot of hot dogs in a little bit of time. He wants to know how many minutes it would take him to eat 35 hot dogs if he kept up that same pace. Those are the types of problems we're going to work on a little bit today. Giving a little realistic spin to it. But overall, our goal, our learning target is to solve proportions. All right, that was a proportional situation that we just were introduced to, and we're going to be working on solving proportions in this lesson. Something that you've done before, something that you might remember how to do, something that we're going to review and we're going to challenge you a little bit with as well. 3 things I'll put on here. Be able to use the cross products property. We'll talk about that a little bit. Maybe you remember it. Solve equations using inverse operations, which, hey, we've been doing that for all chapters so far. And just a reminder here for bullet point number 3, what you do to one side, you have to do to the other. So we are going to be doing some solving equations. That's part of proportion, but we have to get to that, and that's what we got to work on first. So a couple of vocabulary terms here. First one, a ratio. Make sure you have these written down. A ratio is a comparison of 2 numbers, usually in fraction form. Okay? So if you're comparing, for instance, in our original one, Nathan can eat 21 hot dogs in 6 minutes. You might compare 21 hot dogs in 6 minutes. And I put the labels on there because they are really important. So that would be a ratio. A proportion is an equation that sets 2 ratios, or that states 2 ratios are equal. So if you said that 6 over 20, or 21 over 6 is equal to something over something, that would be a proportion. So it kind of looks like this. Use a different color. We have A, B is equal to C over D. That's a proportion. Might look familiar. We're going to use some. We're going to use them with numbers as well. So I'm going to give you an example of what we're going to try to solve today, at least to start. It says 6 over A equals 3 over 8. We want to try to solve for A. Now, looking at that, you might say, well, I can do that. I know that to get from 3 to 6 is times 2. So, hey, I'm going to do times 2 here. And 8 times 2 is 16, so A is 16. Boom. It works. Yes, that's right. And that is one way you can go ahead and solve proportions, but that is a very limited way to solve proportions because it's not going to always work. What happens if I give you an example like this, where you might not be able to figure out how you get from 6 to 5, or so you can go from 14 to n? You got to find another way to solve it. What if I give you one like this, where I've got a b plus 5 on one part of the proportion? What? Yeah. But we're going to talk about the one way that you can use to solve any proportions, and it's something you've been taught before, so it's really a review. You just haven't done examples like this bottom right. This one's a little more challenging. So that way to solve a proportion is what was part of our success criteria. It's called cross products, or the cross products property. So cross products really is the cross products are always equal in a proportion. So meaning products is multiplication, just remember. So if I am looking at this example right here, my cross products would be multiplying across. So A times D, so I'd have A times D, and B times C, and I put them equal to each other because that's what cross products are. That's the cross products property. The cross products of a proportion are always equal. And you can test any proportion with all numbers, and it'll work. So what we're going to do is use that here to solve these proportions. So I'm going to give you, let's take a look at this bottom left right here. If I use the cross products, or the cross products property, I'm going to multiply across. So I'm going to do 6 times n. And that's 6n. And that's going to be equal, we said equals, the other cross product, 14 times 5. Now 14 times 5 is 70. So I've got 6n equals 70. And then that's just a one-step equation. All I got to do here is divide by 6 on both sides to solve it. And I get n equals whatever 70 divided by 6 is. I don't know if that's going to come out to be a perfectly perfect number, so we can check it on the calculator. 70 divided by 6. I get 11.6 repeating. So you can write that, or you can reduce it as a fraction. 70 over 6, if you divide them both by 2, you get 35 over 3. That would be 11 and 2/3. So that would be our answer for n. Again, I couldn't do that in my head. I couldn't do that without figuring out that I could use the cross products property. Now what we just did there, let's just put it into a procedure so you can write down the steps for what we did. Very simple. And the procedure for solving proportions would be first to find the cross products and set them equal to each other. Okay, multiply across diagonally. And then steps 2 and 3, just dealing with what we would normally do in solving an equation, because what we have is an equation after we do the cross products. So let's try it on this little more challenging one. Let's take our proportion. Let's do cross products. Now this one's going to be easy, 7 times 5. This other one, b plus 5 times 10. Now the way we're going to write that is, I'm going to put the 10 in front, and I'll show you why. The b plus 5 is one whole number, so I have to put that together. I have to use parentheses there. Now if you look at that, by the way, I said I'm equal to each other because cross products are equal. If I look at this, you might recognize the distributive property, where I can take that 10 and multiply by the 2 parts on the inside, distribute it like the wave going over over the parentheses. So when I do that, well, the left side we know is going to be 35. That's weird. Equals the right side, which is 10 times b, so it's 10b, equal or plus 10 times 5, which is 50. I'm not sure why it's showing up as an eraser for my pen, but we're going to work with it. Now I'm left with 35 equals 10b plus 50, and it's an equation. It's actually going to be a two-step equation. So let's get rid of what's not. We're going to work on the side with the variable. We're going to get rid of what's not attached to the variable first. So this plus 50 is going to be minus 50. Do the inverse, and I'm going to minus 50 on this side as well. Cross that out. So I'm left with negative 15 equals 10b. Now finally, I'm going to divide both sides by 10. And I end up with b equals, that's negative 1.5 I divide it out. Now the third step would be to check. So if you want to plug that in, if you wanted to plug that in for the original, I'm going to erase this so we can see it a little bit better. It would look like you just plug in negative 1.5 for b. So negative 1.5 plus 5 is actually going to be 3.5. So when I've plugged that in, this becomes 3.5. And then if you divide 7 by 3.5 and 10 by 5, either way you get 2. So both sides are equal. So that's using cross products and then solving it. I want to go back to that one example that we did at the beginning of, well, we'll come back to it at the end actually. I want to do 2 examples that are actually on the practice worksheet for this level. So numbers 2 and number 6. Let's go through these 2. Number 2 is a little bit more basic. Number 6 is going to be a bit of a challenging one. So in number 2, if we use our cross products property, I get 28 times x, which is 28x. And that's going to be equal to 24 times 7, which I have no idea what that is. So I'm going to pull up my calculator again. And 24 times 7, I get 168. So 28x is equals to 168. And there's only one step to solve it. That would be dividing by 28 on both sides. I get x equals 168 divided by 28. 6. Nice. You can plug it back in to check. It'll work out that they're equal on both sides. Now the one on the right, number 6, is a little bit more involved because there's a lot more going on. But we're still going to use cross products because it'll always work for proportions. So if I do this first one, I've got 6p minus 2 And if you recall from before, I said put the other number on the front, and it'll make more sense because either way you're multiplying the two things together. And on the right side, we'll do our 7 times 5p plus 7. Now, both sides have parentheses. Both sides have something that looks like you should be distributing, and that's exactly what we're going to do. We're going to distribute first. If you can ever distribute in an equation, you should always do that first. So I get 48p minus 8 times 2 is 16. The right side, we got 7 times 5p, so that's 35p. Plus 7 times 7 is 49. Now we have an example where there's variables on both sides. So think back, what do we do when there's variables on both sides? What we want to get rid of the variable term from one side. And we're not just getting rid of the number in front of it, we're getting rid of the whole term. So I'm going to work with try to get rid of the smaller one. If I get rid of the smaller one, I subtract 35p, and I'm going to subtract it from the other side, from the p. And then what's left over is 13p minus 16 equals 49. And now we have two steps, and they're on the variables on one side, so I'm going to work on that side, and I'm going to add 16 here. Probably should have used green there to show the inverse. But I have 65 equals 13p. And last step would be dividing by 13. And you actually get p equals 5 when all this is said and done. So cross products is still the first step in solving a proportion, and then it's just knowing our steps to solve an equation after that. So make sure you have both of these written down. They're going to be coming in handy when you get to the practice. But I do want to revisit our opening question before we finish this up. It says Nathan can eat 21 hot dogs in 6 minutes. So we already wrote that out as a ratio. We know he can eat 21 hot dogs in 6 minutes. He wants to know how many minutes it would take him to eat 35 hot dogs. So we have 35 hot dogs in how many minutes? So we're going to keep the 35 up here on top because that's consistent. We have hot dogs on top on both sides, and we don't know the number of minutes there. So we can either leave it as m, or we can leave it as an x, a variable. But when we cross multiply, ignore the labels then, except for that one variable. We're going to do 21 times m. Again, this is a word problem, but we just set it up as a proportion, and then we can solve it. Equals 6 times 35, which I don't know what that is again. I'm not a genius, or I don't have these memorized. 35 times 6, so 210. So 21 m equals 210. And finally, we can divide by 21 on both sides. M equals 10. That means it would take them 10 minutes to eat 35 hot dogs. Not bad. Not too bad at all. It's a lot of hot dogs. It's kind of gross. Either way, that brings us back to our learning target. Ultimately, we were trying to solve proportions, and I think we did that. And I'm hoping you feel a little more comfortable with solving proportions, especially those multi-step ones. I hope you learned something today. Have a great day. Hope you can move up. Hopefully, you can move up in the ranks pretty soon. We'll see you next time.